Now we're going to look at defenses against diseases. Now that, of course, is really just the same thing as maintaining homeostasis. A disease is a disruption in homeostasis, and defending against disease is trying to maintain homeostasis. How do people get diseases? Well, very often they get diseases from microbes. Microbes are colloquially known as germs, which are microscopic living organisms, including bacteria, which cause things like strep throats, protists, which cause other diseases, fungi, cause things like athlete's foot, and viruses, which some scientists don't consider living things, but whether they're living or not, they could certainly make people very sick. Pathogen is a germ or a microbe that uses another organism as a host, really a parasitic organism, and some examples include that pathogens cause strep throats, colds, coughs, bronchitis, flu, cholera, chickenpox. Virtually any contagious disease is caused by pathogens. How does the body defend against that? Well, the bodies have immune systems, and the immune systems try to defend against these pathogens. One, non-specific external barriers, things that try to prevent microbes from entering the body. Things like skin even, doesn't say over here, but tears, saliva, mucus, these are things that kind of try to block the microbes from coming into the body. Then there are immune responders that try to engulf or destroy them. Things like the white blood cells. Inflammation, fever, are natural killer cells. These are things that are caused when your white blood cells, when your immune system is trying to fight off the pathogens. It causes an increase in energy level of the body, and that's what causes a fever, because it just causes everything to heat up because there's so much more activity in there. Then you have specific internal barriers, which is the adaptive immune system. The adaptive immune system is the sort of thing the body learns to fight. When you get a particular type of disease, a particular type of virus, the body then develops antibodies in order to fight it off next time around. That's really the way vaccines work. First you get, and we'll discuss this a little bit later on as well, but when you put a disease in the body, that teaches the body to fight it off next time it comes around. The immunity cells the immunity system, the system that your body uses to fight against pathogens, includes white blood cells, lymphocytes, which are specialized white blood cells. In the adaptive immune system, you have B cells and T cells, and what those do is they help develop antibodies which fight off specific foreign invaders. Tissues and organs that are important to the immunity system include bone marrow. That's where blood cells are created. You may remember when we discussed the blood, the bone marrow makes the red blood cells, while bone marrow makes the white blood cells too. That's, of course, one of the reasons why bone marrow is so important. The lymphatic system, which includes the lymph nodes, which have macrophages, which are things that kill germs, and lymphocytes, which also kill germs, aligning the narrow passages where the lymph flows in between the cells. The thymus is located slightly above the heart, which develops T cells. You could call it one of the endocrine system. It's like here in the body. You can see here's the thymus. The thymus is, it looks kind of in between the lungs. The heart would be somewhere around here, so it's kind of pretty close to the heart and in between the lungs. You also have the spleen. The spleen, which is a little bit lower in the body. The spleen is a little bit closer to the stomach. Here's a little diagram of where the spleen is over here. You can see here's the stomach and here's the spleen. And that filters the blood. And there are also some other tissues in the body that are important to keep germs out, including your tonsils, leukocytes, and things like that. Leukocytes are white blood cells that specifically attack and destroy invading cells. And they even attack the body's own cells if they become a danger for whatever reason. One group of leukocytes are called phagocytes. Phagocytes are basically any type of cell that surrounds and destroys another cell. Really, something like when a cell tries to capture something by surround it, is sometimes referred to as phagocytosis. So phagocytes are kind of white blood cells that kill other cells or kill viruses or bacteria by surrounding it and crushing it. Inflammatory response is when the body uses inflammation as a defense mechanism. If you have a wound with tissue damage, so the white blood cells and the defense mechanisms of the body inflame the area which blocks it so that it cannot be easily invaded by germs. A fever, and this we discussed already, if a population of microbes succeeds in establishing a major infection, the body might produce a fever. One of the things, by the way, a fever does is it increases the body temperature and causes the invaders to be able to function less efficiently. Then there are the specific disease-fighting cells. Disease-fighting cells include T cells, which we discussed are lymphocytes, cytotoxic T cells, which are cells that destroy infected body cells or destroy cancerous cells. And then there are memory T cells. Again, I'm running through this because I don't want you to try to memorize every single word over here, but just the concepts over here. These are things that you develop in order to fight off future infections. So, for example, if you're stung by a bee for the first time, redness and swelling may occur at the site. And the reason for that is, obviously, the body is inflaming, trying to make sure to prevent foreign invaders from coming in. If you have another reaction that occurs more rapidly, it means the body has learned what the chemicals that come in from the bee sting are and how to react to it. So now let's segue to until now we've been discussing what you do, what your body does about foreign invaders that threaten to cause problems. Well, now what can you do from outside your body? What can you take to help your body fight off invaders? One thing you can do is take medicine, which can be good in some ways because it decreases pain and can fight off the infection. But the negative is that sometimes it doesn't let your body do what's necessary to fight off the underlying cause. For example, an aspirin is taken to reduce fever. But remember, sometimes the body intentionally causes a fever by increasing the activity of blood cells and to slow down the viruses. If you kill off your own fever, again, I'm not saying that you shouldn't take aspirin. I'm not saying you shouldn't take Advil or anything like that. But for a minor thing like we have, like a cold or a strep throat or something, is probably not that big a deal anyway. Our body in the long run is probably not going to have much of a tough time fighting it off. But always squashing a fever, always making sure to knock down a fever, might actually hamper your body's ability to fight off the infection. Also, anti-inflammatory drugs can be very good for sports injuries. I've taken anti-inflammatory drugs when I had a back problem, but that's neither here nor there. Inflammation could hamper your ability to function properly. It could be very painful, and it could make it difficult to play sports and do other activities. And anti-inflammatories can prevent the inflammation, but remember, sometimes the body specifically inflames the part of the body in order to prevent germs from entering. And if you take anti-inflammatory drugs, that could kind of increase the risk of contracting infections because the inflammation is no longer there. You could also try to acquire immunity through something called a vaccine. Vaccines are applicable today, are available today for many, many different types of diseases. Measles, mumps, we all take. Chickenpox, most people get. Smallpox, we don't get the vaccine for anymore, but that's because it was destroyed by vaccines. Smallpox was a very deadly disease back in the 1800s also as well, where people would die from it very often. And eventually they discovered a vaccine, and everybody took it, and the smallpox eventually died out. Now, they still have smallpox in a lab in a few places, but it's essentially died out from our population to the point where we don't even bother taking a smallpox vaccine anymore. So, interestingly enough, some of the issues regarding when the European settlers came over, one of the weapons they used against the Native Americans, against the American Indians, was they gave them blankets which were laden with smallpox virus. Now, the Europeans were immune from the smallpox virus because, well, this was before the days of the vaccine, but maybe they had gotten smallpox before, or they weren't as susceptible to it. However, the Native Americans, who had never dealt with it, the body had never acquired the ability to protect itself, the body had never learned how to defend itself against these viruses, were much, much more susceptible to this. However, the problem with immunity is that immunity through a vaccine or through getting a disease, like when you get chickenpox, usually you don't get it again. It's possible to get it twice, but not very likely. And there are other diseases like that also. You know, smallpox was like that also. If a person got smallpox once, they didn't usually get smallpox again. Which is one of the ways they got to the. I don't want to go through the whole story of how they. Well, I'll tell you why not. When smallpox, which was a deadly disease, a scientist named Edward Jenner, back in the 1700s in England, made an observation that the people who were working with cows didn't get smallpox, and he postulated that the people who worked with cows got a different disease called cowpox, which was relatively harmless, didn't kill anybody, just made them sick for a couple of days, and he guessed that was what immunized them, and he turned out to be right. So basically, what he did was he started rubbing cowpox on people and giving them cowpox, and then the body learned to fight off smallpox, and eventually that caused essentially the disappearance of smallpox from human beings. And chickenpox and other vaccines work in a similar manner. The problem is it only works when the disease is very similar. If the disease mutates a little bit, if it's like a different virus, then it doesn't really work. That's why flu vaccines, there's no such thing as the vaccine for a common cold, because there are so many different types of viruses that could cause the common cold. You can't just pick one particular virus and give a vaccine. Same thing is true with the flu. You get a flu shot, but a flu shot may be effective, it may not be effective, because they don't know for sure which flu virus is going to be the one that strikes you. If the same flu virus that you got the vaccine for strikes you, well, then you'll be okay. Otherwise, you might get the flu anyway, even if you got the shot. So the way essentially it works is that the immune system originally doesn't really know how to fight off the virus the first time, and that causes the body to develop the B and T cells that fight it off. Then, the second time you're exposed to that same virus, like the measles or mumps or chickenpox or whatever it is, so then the body already remembers that it needs to produce these particular B cells and T cells to fight it off. It does so much more quickly and more effectively, and you don't get sick in the first place. And you can see here's a little chart that demonstrates how much faster the first time the body reacts the second time around. The first exposure, it may take a week before the body starts fighting it off, and it might take 3 weeks before you get better. And then, after many years, you get it again, and now within the first week, the body has already produced enough B cells and T cells to fight off the whole thing. Remember, T cells are the main thing that fight off the viruses. Now, there are, of course, diseases of the immune system, including allergies. Allergies cause our bodies to have sharp reactions, inflammatory reactions, to things that are ordinarily harmless, like pollen. You take pollen, and normally is totally harmless, floats in the air in the springtime, but if somebody has an allergy to it, then the nasal, the bronchi, the bronchi, the bronchial tubes, the lungs can get inflamed just by exposure to a substance that would otherwise be harmless. There are also various types of autoimmune diseases, which in the immune system gets out of control and attacks the healthy tissue, which obviously is not good. And it could be hereditary, it could be something that you're born with, or it could be acquired. AIDS, which is a famous disease, stands for Acquired Immunodeficiency Syndrome. HIV is human immunodeficiency virus. That's a disease where the immune system doesn't work properly. And if the immune system doesn't work properly, even minor infections like colds and whatnot could be very harmful or even fatal. So here's the human immunodeficiency virus is caused by the AIDS actually causes HIV. The acquired immunodeficiency syndrome causes human immunodeficiency virus. And what they do is they undermine the immune system by infecting and destroying T cells, which normally fight off the bad guys, the germs. And there's no effective vaccine against AIDS, but although in today's day and age they do have drugs that keep. In the old days, in the 80s, whatever it was, people used to very often die within a couple of years of getting HIV. Now, very often they have, people can live many years even after contracting the HIV virus. Okay, so let's look at some multiple choice. And the immune cells of Lisa's body have identified some body cells with a specific virus. Which of the following will destroy it? Well, remember, the things that destroy the white blood cells that destroy viruses and destroy foreign invaders are typically the T cells. Cytotoxic T cells, there are other types of T cells, but here the T cells are the ones, or generally speaking, the ones, well, I wrote T, but it's actually choice E over here, because those are the things that destroy the infected cells. Joanne is a kindergarten teacher and makes sure to get a new flu shot. Every single year she has to get a flu shot, as opposed to, chickenpox where you get once in your lifetime. Why is this necessary? Well, the flu is caused by either bacteria or viruses, depending on the year. That's not true. I mean, the flu is always caused by viruses, not bacteria. The shots do not result in the production of memory cells. They do. All vaccines do. Flu viruses mutate rapidly. That's true. They change a lot, so the next time they come around, it might be a different virus causing it, as we discussed. And the antiviral chemicals in the flu shots only last 11 months. That makes no sense because their flu shot is not antiviral chemicals. A flu shot is the virus itself, which gives your body immunity via the vaccination process.